All right, today we're going to do optimization, day 1 and 2. Both days are 4 problems. The second day, 4 problems, you can just try those, and I'll post the answers here. For the first day, let's get started with these first 4 problems. So optimization means to maximize or minimize something. First one, we are maximizing revenue. Lenny has found that daily revenue from his lemonade stand is a function of the unit price P he charges per cup of lemonade. Using the algebra, find the unit price P that should be charged and the maximum revenue. All right, just looking at this graph, we know it's going to be a downward facing parabola. So our job is to figure out this point right here. That's called the vertex. To find the coordinates of that vertex, first you're going to do is find the independent variable's coordinate. So in this case, the independent variable is P. The formula for this is opposite B over 2A. So what is B, what is A? Well, remember, the standard form of a quadratic would be y equals ax squared plus bx plus c. So a is in front of x squared and b is in front of x. So in this case, it's opposite of 64 over 2 times negative 64. So that'd be 1/2. Think about this in terms of the problem. This is money. So P is 1/2 of a dollar, or 50 cents. So the answer to A, Lenny should charge 50 cents. And to find B, we're just going to put 0.5 into our equation here. All right, we can go to the calculator to do the rest of this here. So negative 64 times 0.5 squared plus 64 times 0.5. We should get 16. So $16. So if Lenny charges 50 cents a cup of lemonade, he will make $16. All right, now we're going to maximize area. Jody wants to fence a rectangular garden along one side of her garage. She has 50 feet of fencing and does not need to fence the side along the garage. So let's draw a quick picture here. Doesn't need to be perfect. There's my garage. In case you didn't know, I'm going to write garage there. All right, and she's going to fence in 3 sides next to that garage. We don't know any of the side lengths, so let's make up variables. I'll call this side length x and this side length y, which means this other side on the right will also be y. Since this is a rectangle, the 2 opposite sides are congruent. We are not going to put an x here because we're not fencing that side. So question A says, write a quadratic equation in standard form for area. Well, it's just a rectangle, so I know that area is going to be x times y. That's not really a quadratic equation. What we need to do is we need to get rid of one of those variables. So we need another equation that we can manipulate. And that comes from here. 50 feet of fencing. So I know that x plus 2y must equal 50. Okay, where did I get x plus 2y from? X and 2y. Solve that for either one of the variables, whatever one's easier. In this case, I think x would be easier to solve for, because all we got to do then is subtract the 2y. Now back in our original equation, let's replace x with 50 minus 2y. And now my area equation becomes 50 minus 2y times y. And if I distribute the y, I get 50y minus 2y squared. writing that in descending order. Not that you have to, but it does make things easier. There is my quadratic equation in standard form. Part B says to find dimensions that will maximize the area. So remember our equation that we found the last number 1 here is opposite b over 2a will find the independent variable of the vertex. So opposite of b over 2 times a. So that would be 50 over 4, which is 12.5. That's one dimension. To find the other dimension, you're going to put that 12.5 in this equation here, and you're going to get 25. So what dimensions will maximize the area? 25 by 12.5 feet will maximize the area. And finally, the largest area that be enclosed. There's a couple of ways you could do this. You could take this y value and put it in your area equation. But why do that when all we need to do is multiply 25 times 12.5 to get the area of that rectangle. And that would give us 312.5 square feet. A farmer with 6,000 meters of fencing wants to enclose a rectangular field and divide it into 3 plots. So let's go ahead and draw that. We have a rectangular field. And we're going to divide it into 3 plots. So we're going to call this side y and this side y. And we're going to call this side x and this side x, but these are also going to be x because those are all equal to each other. So we'll find the largest area. Once again, our area equation is going to be x times y. But once again, we need to get rid of one of those variables. So good thing we have this. So we can set up the equation. 4x plus 2y equals 6,000. Solve this for either one of the variables there. It's probably easier to solve this one for y. And then substitute that into the original area equation for y. Distribute the x. And we go ahead and write that in descending order. And here we have our quadratic equation. So opposite of b over 2a gives us 3,000 over 4, which is 750. All right, so this question doesn't ask you to find y. It doesn't say find a dimension. It just says find the largest area. So you don't need to find y. You could just take that 750 and substitute it in our area equation right now. Now, if you wanted to find y and then do x times y, that's fine. Or you can just find our largest area right now. So negative 2 times 750 squared plus 3,000 times 750. Gives us an answer of our largest area of 1.125 million square meters. All right, last one. Toy shop sells 50 Action Max dolls per week at $20 each. So right now, $50 Action Max dolls at $20 each, they're making $1,000 a week. The shop manager estimates that for every 50-cent decrease in the price, they're going to sell 5 more dolls. Let X equal the number of 50-cent decreases. All right, so now our revenue equation. So we'll call it R of X. I know 50 and 20 are my current numbers. So every time we decrease the price 50 cents, so 20 minus 0.5x, we sell 5 more dolls. So 50 plus 5x. If we multiply that out, we get 1,000 plus 100x minus 25x minus 2.5x squared. And combine like terms and write that in descending order. There's your quadratic function in standard form that represents total weekly revenue. So now we need to find our independent variable of the vertex. How should doll be priced to maximize revenue? As soon as we see maximize or minimize, we know that we need to find the vertex. So this is 75 over 5, which is 15. Okay, that is not the answer. Okay, that's how many times they should decrease the price 50 cents. Okay? So remember, this expression right here is your price. So 20 minus 0.5 times 15. Let's see what that is. $12.5. So they should be pricing it as $12.50. How many dolls will be sold? Well, this is how many dolls are sold. So 50 plus 5 times X. Would be $125. So weekly revenue, there's 2 ways to do this. You could just take your 15 and substitute that back in here to find R of 15. Or, since we know that they're going to sell $125 at $12.50, we can just multiply those 2 together. And we get a final answer of $1,562.50. So the next 4 problems I'm just going to ask you to do on your own. You can pause the video after each one and check the answers. I'm just going to scroll through them and you can check as we go through. So pause the video right now and try number 5. Come back when you've completed it. Here's the work and answer for number 5. Well, the second number 1, day 2, number 1. Same thing, pause the video and do day 2, number 2. Work and answer for number 2. Pause the video and try number 3. Work and answer for number 3. Pause the video and try the last one, number 4. And there you go. That ends our optimization lesson. Email me with questions as always.